All right, we're going to look at some applications of trig now, which, by the way, is 11.2 in your book. So far, what we've looked at is in right triangles, we said how we have trig ratios that could be used to solve problems. And then we said in non-right triangles, we have special rules called the sine rule and the cosine rule, which can be used to find missing sides and missing angles. And we also said how you can find the area of a triangle, whether it's a right triangle or not. So we have some formulas for that. So now we're going to get into some applications. So the first type of application here deals with a word problem where we're talking about either the angle of elevation or the angle of depression. So understand that both of these are based off of a horizontal line. Okay, that's kind of like your starting point. So maybe you're talking about the ground as your horizontal line. In that case, we're dealing with, let's say, an angle of elevation. That is always going to be the angle that rises up, okay, above that horizontal line. Sometimes we'll see word problems where we're talking about someone standing on top of a building. Then you might see what's called an angle of depression. So the angle of depression is that angle that stems down from that horizontal line. So once again, everything is based off of the horizontal line. Okay, let's look at an example. Okay, take a moment please and jot down this example. We're talking about a man who is standing atop a building looking at a car 200 feet away with an angle of depression of 10 degrees. We want to find the height of this building. So buildings, we're going to assume, are built horizontally. All right, unless it's like the Leaning Tower of Pisa. But we're going to say that we have a horizontal building. And so we have a right triangle here. Okay, so here is the building, okay, and we have this person standing on top of it, okay, and here is the car, all right, there's my awesome illustration of a car, whatever. So it's 200 feet away, and we're told that the angle of elevation is 10 degrees. So this is where it gets tricky. The biggest mistake people will make is they want to put a 10 right there. Okay, do not put your 10 right there. So let's erase that. Instead, what we want to do is draw a horizontal line. Okay, so here is my horizontal line from where we're standing. This is not drawn to scale, okay, but pretend it is. So the angle of depression is right here. It's actually outside of our triangle. And so, since this is supposed to be a right angle, okay, the horizontal line and that vertical building is supposed to be a right angle, that means our angle inside the triangle would have to be 80. So if we're going to find it, if we're going to find x, notice that this x is an adjacent side and this 200 is a hypotenuse. So go ahead and solve this using a trig ratio. So hit pause. Alright, so if you did this correctly, you got 34.7. Make sure you use cosine since we're dealing with an adjacent side over hypotenuse. Okay, so the building would be 34.7 feet. On to the next one. Okay, next we're dealing with what we call compass points and three-figure bearings, or sometimes we just call it bearings. First, we're going to talk about compass points. So you know what a compass is, so north, south, east, and west. Hopefully you know the directions of those four. And typically, guys, this is going to show up in word problems where you're given directions of, things like a ship moving on the sea, following a certain compass point direction. So if we were to talk about, for example, if you see N and then 40 degrees and then E, that means 40 degrees east of north. So you kind of work backwards here. You look at this part first, okay? It's 40 degrees east and then of the first part. So if we were to draw this up above here, 40 degrees east of north, all right, would be this angle inside here, okay? So this is what we mean by north 40 degrees east, okay? So it's 40 degrees east of north. Likewise, if we were to locate where this next one is. This is saying 20 degrees south of west. Okay, so 20 degrees south of west. Well, west is to the left there. 20 degrees south of it would be this little sliver of an angle. So this is the direction for west 20 degrees south. Now, sometimes you might see something like just NW. Well, this means that you're going to have a 45-degree angle between north and west. So you would be splitting the quadrant here. Okay, so northwest would look like that, and that would mean that you would have 45 degrees in each side of that. Okay? Okay, next here we are looking at what we call three-figure bearings, or like I said, just bearings in general. So you're always going to be told in a word problem that you have a bearing of whatever, right? And you'll see 3 digits, 3 figures. So these give directions as angles measured clockwise, okay, from the north. This is not an angle in standard position, okay? Where in standard position you're really starting from the east, right on the x-axis there, and you're actually going counterclockwise. Here we're going clockwise from the north. So from the north really means we're starting here and then we're moving clockwise, okay? So in that direction. So if we're looking at a bearing of 035 degrees, so from the north, so starting right here, we have to travel 35 degrees, okay, in a clockwise manner, okay? So we're talking about this angle in here, that would be 35 degrees, okay? 110 degrees. If it's a bearing of 110 degrees, again, the key word would be bearing in a word problem. So from the north, if you were to go 110 degrees, well, you'd have to go at least 90 degrees to get out of that quadrant, and then you would have to go down below here, okay? So we would travel 110 degrees, all right? A bearing of that amount would look like this angle, okay? So that would be 110 degrees for the bearing, okay? Sorry, I'm having trouble writing here. 270 degrees as a bearing. So once again, measured clockwise from the north. So if we're going to go 270 degrees, all right, as a bearing, this would actually be the same as saying that you're traveling due west, right? Because you would actually be going directly west, okay? So these are all referring to bearings, okay? Okay, take a moment please and copy down this example. So, and again, feel free to paraphrase, okay? So we have 2 ships that leave dock at the same time. All right, so this is going to be our point that represents the dock. Ship A, this is the ship that sails due north, so that means it's heading exactly north for 30 kilometers, okay? So it's going to travel for 30 kilometers before it drops anchor, okay? So we're going to call this A, because that's where ship A is now. It's anchoring at sea. Ship B sails on a bearing of 050 degrees for 65 kilometers. So again, it's leaving from this dock, call it D. Now if the bearing is, so we have the bearing, if it's 50 degrees, remember bearings are always measured clockwise from the north. So what that would mean is we have a angle of 50 degrees. We're not going to write 050, it's just 50, okay? And we have this ship B, it's traveling for 65 kilometers, all right? So I'll label this B. This is where it has now dropped anchor, okay? We want to find the distance between the ships when they're stationary. So they've both anchored. This is what we're trying to find. Well, we actually already found this distance x. If you look under the cosine rule, we said that x was equal to the square root of 30 squared plus 65 squared minus 2 times 30 times 65 times the cosine of our angle 50. And recall that we got 51.2. okay? And it says to the nearest kilometer, so 51 kilometers would be our answer here. Okay, so you have to know how to draw this. Okay, so we're going to look at some more examples where the focus is mainly on drawing it. Alright, so in this task here, what we're just looking to do is sketch a picture to model the situation. We're going to end up with a triangle, usually in all these word problems, and then we're not going to worry about solving for any angles or sides. You know how to do that from either your sine or your cosine rule. So our focus here is just on drawing the picture. That tends to be the most difficult part for people. So suppose you are walking 10 meters due west. So we start here, and let's say we walk 10 meters, okay, west. So the arrow indicates that we're traveling that direction, okay? So then we're told that we turn and we walk 30 meters on a bearing of 250 degrees. So to help you do this somewhat accurately, from this endpoint right here, all right, where you're about to turn and change your direction, oh, please excuse my dog barking once again, draw your north, south, east, west lines, and keep in mind that a bearing of 250 degrees, all bearings are drawn from the north clockwise. So if I were to draw 250 degrees from the north and clockwise, that is going to put me down here, okay? So this is going to be my new path. I'll do this blue like the other one, okay? And I know that I'm going to be traveling for 30 meters down that path. So keep in mind that this was a 250 degree bearing for the angle. Well, what that means is that if that's 250, this would have to be 20 for that angle, because 250 plus 20 will give me that 270, all right, which would be due west actually, right? So if that is 20, then this top angle must be 160, since that 20 and that 160 are back to back or adjacent. They're supplementary, okay? And so usually what you're going to see is word problems where maybe they want you to find the distance from where you started to where you ended up. So sometimes it's helpful to recreate the triangle, all right, to draw it over with just the critical information that you would need inside of it. Okay, it's not a very good triangle, but you get the idea. Okay, so that obtuse angle would be 160. You get that just from doing some basic geometry. Okay. All right, last one. I apologize. I know this video is getting kind of long. So we're just looking to draw this. All right, so we have town A, that's 30 kilometers from town B, in the direction of this compass point. So we'll call this our town A. We have town B in the direction of, now we're told, north 35 degrees west. All right, so you want to get in the habit of drawing your north, south, east, west lines. So 35 degrees west of north would put us over here. Okay, so I'll make this nice and big for us. So this angle right here would be 35. Okay, so again, make it clear that you are drawing your lines in here. This is our north direction. Okay, so we're showing that that is a 35-degree angle. Okay, by the way, this angle right next to it here would have to be 55, since we're talking about north, south, east, and west. They'd have to add 90 degrees, right? So at the end here, we would have our town B, and we are told that this is 30 kilometers away. All right, from there, we have town C, and this town is north 25 degrees east of B. So stop for a moment, and at B there, let's draw again our north, south, east, west lines in. And from there, we need to go 25 degrees east of the north direction. Well, this is the north direction, right? So if we go 25 east of that, well, that's going to put us right here, okay? So this angle is 25, right in there, okay? and my town C, all right, is, let's call it up here. Sorry, I'm running out of space. Okay. And so we know that that is, we're told B and C are 40 kilometers apart. So that is 40. Okay. And so if we were to just continue to try to fill in some of these pieces in our diagram here, sometimes it's helpful to make right triangles, all right, around some of these lengths. If that is 55, then we know that this angle in here would also be, well, this would be 35, since we have alternate interior angles, right? These are parallel lines, so we would have alternate interior angles, all right? That's helpful because if we know that this angle is 35 and this angle is 25, they add up to 60, which means this angle on the inside must be 120, since this is a straight line, and all these angles must add to 180. So we're just using some basic geometry facts there, okay? Now, sometimes you're going to want to redraw part of this diagram. So if I were to recreate this, this is A, B, and C. This distance is 30, this distance is 40. We know for sure that this distance is 120. You might be asked to find that distance between A and C. Okay, that's what typically you'll be asked to find. So we don't know those other angles at this point. Be careful, this bottom angle A is not 35. That 35-degree angle was that distance here between the north direction and that line. So while it's close, if you were to draw A to C, it's not exactly along that path, okay? So be careful there. So we do know enough where we could use our knowledge of either sine or cosine rule to find missing sides and missing angles if needed, okay? Sorry for the lengthy video. I hope you'll forgive me. Bye-bye.